Okay, so let's talk about this gram-positive, gram-negative business. So bacterial cells, they kind of come in two varieties, right? So your gram-positive bacteria have their cell membrane like all cells have, and then they have this really thick peptidoglycan cell wall, right? And we've talked about this before in earlier experiments. They have this cell wall. A gram-negative bacteria has the same plasma membrane and the peptidoglycan, but it has this outer layer of lipopolysaccharide, which just means lipo means fat, polysaccharide is a sugar. So it's sort of this oily, greasy sugar fat layer on the outside of the cell. And it's named after a guy named Gram, right, who created the test. And so what you do is you take the bacteria and you put the Gram stain on it, the purple stain. And if it's this gram-positive bacteria, the purple soaks into this peptidoglycan. But if it's gram-negative, this slime layer prevents that dark purple stain from getting in. Then you wash them both with alcohol, so that's going to remove that slime layer. And then they add like this light pink dye. Well, this one's already purple, so it doesn't take in any more dye. I mean, it does, but you can't see it. Whereas this one, the little cell wall here, will take in that pink. So if they're pink, it means they originally had that slime layer and they're gram-negative. If they're purple, it means they never had that slime layer. They took in the first stain and they're gram-positive. So I know it seems counterintuitive. If it's positive, it means it doesn't have the slime layer. If it's negative, it means it does, right? But it has to do with the stain, whether the gram stain shows up. Okay, so you should have been able to go through and look at these and say, okay, so the three types of antibiotics that harm bacterial cells, if we go back and look at them, Cipro blocks an enzyme that stops over-twisting. Streptomycin blocks bacteria that are specific ribosomes need protein synthesis, and amoxicillin blocks the enzyme that links amino acids and sugars in the peptidoglycan molecule that's present in the bacterial cell walls. So amoxicillin is the only one that's working on the cell wall. All right, so a gram-positive bacteria is the one that has this giant cell wall. All three of these should affect it. But a gram-negative bacteria, if we're treating it with an antibiotic that's specifically attacking that cell wall, it can't actually get to it because of the slime layer over top. So it's not going to respond to amoxicillin, right? Whereas eukaryotes aren't going to respond to any of them because they're eukaryotic. Okay, so we saw above that this particular culprit only responds to 2 of the 3 antibiotics, so that means that it must be gram-negative. Now, I just want to point something out. Did any of you Google this? Because this is my opinion. I'm going to get on my soapbox for a minute. Google is ruining education because it stops students from thinking. They just Google it. And if you had Googled this and just Googled, is Clostridium gram-positive or gram-negative, it would come up overwhelmingly with gram-positive. And so you might have gotten this one wrong, that it's gram-positive, but it's not. And that's because there's actually lots of different species of Clostridium, and Clostridium piliformis, which is the one we're doing in this activity, actually is quite often gram-negative. So this is not a Googling question. This is, we've got to figure it out based on the evidence I've given you in the problem. And based on the evidence I've given you, this appears to be a gram-negative form of the Clostridium piliformis. All right, so anyway, so I hope you didn't Google it. I hope you just used your logic and reason to figure it out, but it definitely is gram-negative.